We had a really great session on Ground Robotics yesterday. So we had 5 fantastic speakers, which I'll quickly introduce, and then I'll let you know what we've been discussing. So we had Chinmay Sonman with us from EarthSense. He's been talking to us about robots for agriculture and how to improve the resilience of our food system. We had Dylan Crow from Renovate Robotics explaining how the roof of a building is a part very vulnerable to weather events and especially extreme weather events, and that it does need renovation over the building lifetime, and how robots can help reduce the risks that come with this very dangerous trade of being on roofs and renovating them. We had Tom Lipinski from QBot that was telling us how his little robots have insulated more than 5,000 homes in the UK already. It was great savings on heating and without the need to move anyone or anything or destroy any floor. We had Jay Wong from Luminous, who built robots that fill in the gap in the labor market for solar panel installation, lifting these very heavy panels to build the solar farms that we need for a more sustainable future. And last but not least, we had Ben Grotsky from Soltrex that works basically on the next step with his robots that maintain solar farms, cleaning, cutting grass, surveilling, and inspecting for good functioning of these solar farms. So altogether, we had a really great discussion around how the various participants are working on fulfilling the main physical needs of human beings, right? Food, shelter, energy. And we talked quite a bit about how robots empower humans and further their skills and basically allow them to focus their brain power on creative pursuits and highly skilled crafts and the real problems instead of spending their time on lifelong back-breaking jobs. And we talked also about how robots can combine the benefits of older specialized techniques that require a lot of labor with the scale of modern productive techniques that can scale better. So we talked as well about resilience, whether it concerns our roofs facing extreme weathers or our crops in changing climate, and how here robots can help implementing techniques that are already known but too costly or too dangerous or too labor intensive to put in place at scale, such as building and maintaining all these solar farms that we need, or insulating the huge amount of existing old buildings that we have instead of building new. And finally, we also touched on how a decentralized but highly networked society should be the future we aim for, and how robotics and AI should be part of this, and on how we need to be very careful and mindful with how we do carbon math, and really only putting out there solutions that do have a net positive impact when everything is really taken into account. So yeah, that's the main topics we've discussed, and I'm happy to hand over to the speakers if they want to contribute their inputs from the session.
Thank you very much for that overview, Audrey. I wanted to be in all these sessions, so it's great to have this report back. That's the whole point. Thank you for taking the time to take those notes and share with us. I see that we have Chinmay here from your team. I think maybe some of the other speakers are running just a few minutes late. So Chinmay, great to reconnect. Thanks for your time yesterday. Thanks for coming back today. Would love to hear your thoughts and highlights and what you have learned maybe from some of the other fellow speakers in your session. And also, since we have the time, update us on what the latest is in EarthSense. Thank you.
Yeah, absolutely. Thanks, Patrick. Yeah, this has been a great summit, great conference, the breakout session. I'm also feeling the same way as you, like, I wish I could have attend all of the breakout sessions, right? Like there's something to learn from all of these. So I've enjoyed listening to the reports back. Yeah, we had a really solid discussion. There were points of common interest and common sort of philosophical approach, common strategic approach. And there were some interesting sort of conflicting viewpoints as well. It was all really good to discuss all of those. From the common perspective, I think ground robots hit people a lot harder in terms of like, oh, are these going to take jobs away? And we brought up, a couple of us brought up the point that just because a job exists doesn't mean that it should exist and it should be done by people, because not all of these jobs are really good, and many of the jobs that we're trying to automate are sort of the classic dull, dirty, dangerous. But more importantly, from sort of the way I approach it, is humans should be doing more creative, more productive, more things that move society forward, things that move humanity forward. And we really should lean into this and somehow better communicate this message that we are creating robots that free up people. So Audrey brought that up quite well. That's exactly what we had all spoken about at some point. As for EarthSense, we are working on sort of mitigate 3 different capabilities that agriculture has, or 3 different opportunities that we have with agriculture, bringing in robotics and AI. So the first one, of course, we want to make sure that everybody has enough food, which itself splits into 2 different parts that EarthSense is helping with. One is to help crop scientists around the world create the next generation of modern crops that are climate resilient, resource efficient, and still highly productive and nutritive to produce enough and good quality food for everybody. So that's one of our biggest impact, though from a startup perspective, from a business perspective, it's really a small niche market, but we like it because we see the catalytic impact of it. And we started with that early back in 2018 and have used revenues from that to organically reinvest our capabilities into larger farmer-focused applications, which is the second part, which is once farmers have better crops, we still need to help them deal with the fact that fewer and fewer people are working in agriculture already, regardless of where you are. So I'm right now in Malaysia, and you'd think that in Asia, with the population being what it is, agriculture isn't really facing a labor crunch, but that's not the case at all. People have been leaving agriculture in droves for the last 10, 15 years with increasing industrialization, increasing urbanization. And again, that is as it should be, right? I mean, most of these crops that were heavily manually farmed, those were not good. That was not kind on people, if you will, right? These are hard, very low paying jobs out in the tropical sun all day for your whole life. Like that's not what we should try and free people from having that burden just because we need cheap food. So our robots that help farmers, large landowners, other types of agricultural systems do agriculture in a productive, climate resilient and sustainable way are our second major product line. This is the Terra Max robots. And then finally, agriculture has a huge opportunity to actually help reverse climate change by sequestering carbon, and not just pulling it out of the air and locking it away, but actually pulling it out of the air and putting it to good use by improving our soils, improving the water holding capacity, drought resistance, fertility, all of these kinds of things that happen when you put more organic matter into the soil. So that's been our third longer term objective that we've started working with some USDA grant funding, a few $1 million. So that's kind of the range of activities that we're doing, but at the heart of it is the Terra AI and autonomy system that we've developed that's quite modular and allows us to create these different solutions for different crops, different geographies quite quickly. We are currently, just as a shameless plug, we are currently raising a funding round to help us accelerate faster. The reason I'm in Malaysia is, the Malaysian, the very controversial and rightfully so, the oil palm sector is also hurting from the lack of labor. And it is the world's largest food oil. So, we can't just ignore it and say, oh, if we don't buy it, it'll go away. It's not going to go away. There's 30 million hectares of it, and we have a huge opportunity to help clean that up. So these oil palm farmers want our robots, and we want to make them, finish the product development and start scaling up manufacturing for that quite quickly. So we're looking for funding support for that. So we'd love to talk to any investors that are in the room. Oh, there's some questions in the chat. Should I answer them now, or how do we go?
Yes, why don't you? And just to also introduce Stefana as well. Thank you, Stefana, for joining a second day for the session. So Stefana is one of the co-moderators, as I mentioned, of the session. But yeah, if you, well, I'm not, it's up to you to decide how you want to manage this. I'm going to step back and just listen and learn.
Yeah, I mean, these are, I can answer these questions quite quickly. So how much AI does AirSense use? All possible AI? No, but seriously, I mean, we have machine learning algorithms that run real time on the robots to help them navigate autonomously through these very challenging, unstructured, dynamically changing terrains. So these are not, agriculture is not somewhere you can create a map and say, okay, yes, robot, go follow that map, because the map is, as soon as you make it, it's obsolete because the plants are growing, the terrain is changing with rainfall and things like that. So our robots actually use onboard edge AI, vision, as well as multi-sensor fusion in order to navigate the terrain, figure out what parts of the field are traversable, how to adapt the robot's traction to traverse through tricky terrain, and then get the job done, whether it's, harvesting or fertilizer application or, transport or any of these things. So these models, we've worked hard from early on. We had very, very small robots. So we, by necessity, we made models that were very, very energy efficient and could run on very low cost compute, very low powered compute, and we'll continue to move forward on that. And then, yeah, as we do more energy intensive tasks, like the compute is not that energy intensive, but for the other energy intensive tasks, like carrying stuff around, applying fertilizer, this can be hundreds of kilograms, if not more, right? And that does require rethinking how we manage energy on the robot. Our answer is, in the long run, it'll be completely battery electric powered, potentially with solar charging on site. In the short run, that's massive leap from where battery capacity is today, and massive amounts of infrastructure that we ask our farmers to build, which we can't. So in the short run, the answer is you have to use a hybrid electric drive. So series hybrid, very efficient onboard fossil fuel powered, but on a very efficient power generator that runs the highly efficient electric drive system, electric power system. So, but we're working with battery manufacturers to make sure that in 3 to 5 years, we can be fully electric. All right. Thank you very much.
Well, I can quickly say hi and apologies that I ran late. That's the downside of academia. Things always run over time. But I don't want to keep up the conversation. I see there is actually a question to Audrey in the chat. So I'll let you jump in.
Yeah, happy to answer that. So thoughts on whether legged robotics might have a role to play in climate action. Sure, I think there's definitely opportunities. I think as a technology, legged robots are still a little bit newer than drones or wheeled robots, so they're a little bit less established, which is why at the moment there's probably less going on in this area. Also, I feel like most of the research at the moment is more in terms of climate reaction, if I can say it that way, in terms of search and rescue, and using these robots when there's a catastrophe, for example, and collapsed buildings, very rough terrain. Like robots would be a great asset because they're able to overcome these kind of obstacles that other types of robots would not. They're able to go into tight spaces and really climb over debris and look for people. So there is quite a lot going on in that area, but this is a problem that is not solved yet. So I hope in the coming years we can see real solutions in that direction. And then in terms of climate action, I'd say at the moment, again, since it's a new technology, there isn't enough interest so that there is enough funding for causes like this. So they're at the moment still mostly industrial oriented, which hopefully eventually should lead to different purposes.
Okay, I can jump in since Patrick left a question for me as well, but I'm very happy to to give a bit my takeaways from yesterday. I think particularly what stuck with me, and it was a really enjoyable discussion, was this question about how much do we want to automate, how much are we going for efficiency, improving volumes, maximizing productivity, etc., and how much do we not want to do this? So the fact that in most of our industries it's not that one-sided, that there's parts of processes where it really makes sense to move towards increased volumes, increased efficiency and all that, and that there's still processes where craft plays a really big role, where human work directly is actually still very, very valuable. And recognizing these two streams as they can go together, and as that they can work together to find solutions for the problems that we're facing. I think that's really powerful takeaway that came out of yesterday. So I'm very glad to have had that.
So I think we still don't have our other speakers. I see in the participant list that we have John Burley, who was here with us also yesterday from QBot. Maybe you have some takeaway from yesterday?
Hi, well, thank you for the invite to pick up where Tom's not available today, but for those of you who don't know, I work with Tom at QBot since the beginning of this year. My takeaway was, well, we talked a bit about extension of people's effective working lives in skilled sectors, which I found, I've seen that in another sector outside of climate robotics, in the medical robot sphere. So it was nice to see that other people had that context of climate robotics being potentially something that would bring in great skills, and people would use the robots to enable them to do work, to scale their work, to leverage their skills, working alongside those robots. So yeah, that was, I'm delighted that I'm not the only one who thinks that's an important piece for robotics.
Thank you. I think we have another question for Chinmay in the chat on what might be the newest battery technologies that you're working with. Silicon anodes, question mark.
There isn't anything specific that I can sort of point to and say, oh, this is what's happening. So we've been having conversations with large battery manufacturers. So SK is one of the biggest battery manufacturers in the world, right behind Panasonic, I believe. It's a Korean company. We've been having discussions with them about how they're gonna do this. They're like, yeah, trust us. We are working on several different, electrode technologies, electrode materials, several different electrolyte materials. So it's, there are several things in action that apparently people don't want to actually tell us, but that they are confident that they can manufacture high capacity, fast charging batteries at volume in the next 3 to 5 years. So some of it, I think, is because they want to hold it confidential, that I can't say what those are, because I honestly don't know. Sorry, Steve.
So I can take just the next question and the connection back to the role of craft, right? What we talked about. We did talk about it, I think, a lot in relationship with construction, since we have the two startups here that one deals with roof tiling and the other one with retrofitting floor systems to insulate them. And in that context, we discussed quite a little bit how not everything is automatable, but also what the role of human workers is, as construction per se is really craft related profession. And I think it's what we all agreed upon, I think, which was really nice, is that it's not one or the other, right? And that there are definitely tasks, and these apply to other industries as well. And in agriculture, we heard that yesterday a lot, that there's a lot of processes which are really not nice for humans to do. This is not what we want people to be working on. So there's processes where it makes perfect sense to automate them, whereas there are still processes, and in particular in construction, I believe. And when working with retrofitting, working with existing structures, it's also really, really challenging. And there's a lot of individual requirements, different materials, etc. Where human craft really makes a lot of sense. And in particular, since we're really looking at how to improve the sustainability aspect of construction, to lower the footprints that we have working with existing buildings and structures, and what we have is really, really crucial. So that role of the craft, I believe, won't really go away in that context. But at the same time, I think it applies to other industries as well. Like it's not a construction exclusive question. It is. We did talk a lot about just the role of humans and workers in these processes. That there always is a social aspect to it, as to certain jobs are required and are for some people really the base of their existence. So I think that keeping that in mind, and finding this nice balance between how can we improve the conditions, how can we improve the processes, while having people involved was a nice output.
There appears to be a question for me in the chat, so I'm happy to pick up on that if the moderators are happy for me to do that. So Ben's asking, can we work with other insulation types, or is it mostly blown fibers? Well, first of all, I'll fess up about the insulation we currently use. We currently use a spray foam insulation, the kind that's been in the building industry since the sort of mid-1950s, I think. Very quite well known, known to be a petrochemical derivative, and also known to have volatiles as part of its ability to expand and fill out spaces very quickly. As I see it today, it's the least worst option because it works extremely well, offers very high insulation values, U values, and it has a very long working life. So if we spray that under a floor, and here in my house in Cambridge in the UK, it's sprayed underneath my floors, so I pay for that. I believe in it. The product is very long lasting, so it's a sort of do once job, and it's the same kind of stuff that's used in fridges and freezers to insulate the walls of those. However, I would be delighted, and maybe this is a shout out to the network, this big network of people who are developing alternatives, cleaner, sustainable alternatives to that kind of sprayed insulation. I would love to progress CUBOT's product forwards. We're not industrial chemists, we're roboticists and software designers. So if there are folk out there who have network connections in the development of better alternatives for the sprayed insulation market, The main challenge we face is moisture. So we don't want to spray something under a person's home that then subsequently rots or degrades quickly and requires us to keep coming back and redoing that, because that is not the message for us. We are trying to do a one-stop insulation that could last 50 to 80 years in a typical home. But yeah, there are other products out there that people know of, or they're familiar with the industry. Please do reach out. I'd love to hear more. It's the least sustainable bit of our work, but it's so it does work. So it's one of those trade-offs in robotics. You can't go to perfect from zero. You have to work your way upwards.
That's another question for you, John. Are there other retrofitting processes beyond floor insulation that QBot is considering for future
Yes, well,
developments?
that's a great question. So when I joined the business, which is now 4 months ago, I saw QBot as a platform, as a rugged robotic platform that can access underfloor voids and spaces. So there are a number of things we've started to work on around the non-destructive testing and identification of problems that you might have in buildings, such as leaks or moisture going to ground under houses, helping people to shore up those problems, identify them with non-destructive testing. And I believe that we will be developing additional kind of, let's say, ability to insulate into different kinds of spaces for the future, particularly for the US market. We're interested in looking at that and finding out what the market need is. Homes in the UK don't usually have basements. And as a result of that, they're small crawl spaces that sort of between, say, 20-30 centimeters up to about 1 meter, or 1 foot to 3 foot in other money. And so those spaces are ideal for a robot, but actually there are other spaces that we could be working in that we're very open to adapting our system. We've done some climbing robots that go up in the homes that have spaces between the walls, the cavity wall insulation. We've done some inspection bots that can get up inside those spaces. We've done some bots that climb on that can do rendering on the outside of walls. These are all prototypes we've played around with while we've been looking into our future. But today's market, the thing we're focusing on right now is the insulation. And the reason for that is that it's every time we do it, we're saving about 0.6 to 0.8 tons of carbon a year in those homes. Forever, pretty much, as far as I'm concerned, what forever means for a building product. So it costs us about 800 kilos of carbon to do the work, and we're paying that back in year 2. So that means of the 5,000 homes we've done, that's 2,500 tons of carbon a year that we've already taking out of the mix. Small to begin with, right? We're not a big company, but it's a lasting and meaningful contribution. So if I'm open to ideas. If there are folk out there who say, hey, I like the way your robot moves and maybe it could do this in this space. We've got some friends who we cohabit with in our space in London called Bladebug. Maybe some of you know Bladebug. And Bladebug are creating a walking robot that climbs around on top of wind turbine blades to inspect them non-destructively. Bladebug have pointed out to us that you can actually go inside these turbine blades and do work inside the blades. So potentially there's an opportunity for us to join Bladebug on that mission to keep the wind turbines turning. Sorry about Bladebug not being able to come. We work closely with them. I know them well. So I won't speak for them, but I will encourage you to take a look at their website and learn about them. They're a wonderful organization. And Stacey's incredible, by the way. So if you get to connect with Stacey, she's amazing. She's spent years out at sea doing marine diving and ocean repair in the oil and gas sector, and has turned a hand to wind and clean tech and clean space. So she's quite an amazing person to lead to champion Bladebug.
Thank you so much.
I
think we're reaching the end of our time, so time to wrap up and leave the space to the next session. Thank you again to all of our speakers, also the ones who couldn't join again today. Thank you to all the participants and the nice questions, and thank you to the Summit organization. We had a really, really great discussion, and I hope this goes further.